Determine the values of the variable for which the expression is defined as a real number. Y equals the square root of 5x squared minus 27x plus 10. So we can think of the given function as the square root of f of x, where f of x is the quadratic function 5x squared minus 27x plus 10, which factors as 5x minus 2 times x minus 5. And when we think about starting with a value of x and inputting it to the function f, since it is a quadratic function, x can be any real number. So no restriction there. When f of x is input into the square root function, however, there is a restriction. F of x must be greater than or equal to 0. So, since we already know how f of x factors, we can sketch the graph of y equals f of x. It will have x-intercepts at 2/5 and at 5. By setting, first of all, 5x minus 2 equals 0, and then x minus 5 equal to 0, and solving for x. So we have a quadratic that opens up. It opens up because the leading coefficient of f is positive. And we notice that the y values of f of x, in other words, the value of f of x, is greater than or equal to 0 from 2/5 to the left and from 5 to the right. So the solution this time is the interval negative infinity to 2/5, including 2/5, union the interval from 5 to infinity, including 5. Values in this union will produce values of f of x for which we can take the square root. So let's look at the other example. Here we have the reciprocal of x squared minus 4x minus 5 to the 1/2 power. And remember that the 1/2 power is the same as the square root. So we can consider this as the square root of 1 over, let's call it g of x, where g of x equals x squared minus 4x minus 5, which factors as x minus 5 and x plus 1. So y equals g of x. We'll have x-intercepts -1 and 5. Now let's think about inputting a value to g of x. Since g of x is a quadratic, we can have any real number. Would we take the reciprocal of g of x, g of x cannot equal 0. That means g of x is less than 0, or g of x is greater than 0. When we take the square root of 1 over g of x, then 1 over g of x must be greater than or equal to 0 because of the domain of the square root. And so, if 1 over g of x must be greater than or equal to 0, then g of x itself will have to be greater than or equal to 0. But since both of these conditions must be true, g of x must be greater than or equal to 0, but g of x cannot equal 0, we know that the restriction is that g of x must be strictly positive. So when we draw our graph this time, we're looking for where the parabola is above the x-axis. Here's -1. Here's 5. Opens up because the leading coefficient is 1. And we notice that to be strictly greater than 0, x will have to be less than -1 or greater than 5. So our solution will be the interval from -infinity to -1, not including -1, union the interval from 5 to infinity. So any number in this union can be used as a value of the variable, and the square root of 1 over g of x will be a real number.